Robert J. Bob Patton retired from Ball Aircraft Corporation, where he was the Senior Vice President for Business Development Operations. He then began consulting for numerous organizations: LTV Aircraft Product Group, McDonald Bought AX Proposal, Israel Military Industries, S Systems, ADL Independent Review Team, and others. He served on the Air Force Scientific Advisory Board from 1993 to 1995. Worked for the Department of Justice for 5 years as a consultant and an expert witness. Bob also participated in National Research Council studies during 2001-2003. During 2005 and 2002-2006, he worked for the Institute of Defense Analysis on the independent JSF review team. Bob spent over 40 years in the aerospace business, working first for General Dynamics in Fort Worth. He worked on the B-26, B-58, RB-57F, and the F-111. He worked on their airplane design and development. Then in Groton, Connecticut, at the electric boat. He also spent 3 years on loan to the Air Force as their Director of Engineering on the B-1A bomber. Mr. Patton returned to Texas in 1976 to work for LTV. He was the original program director for LTV on the B-2, and then he also was directed all classified and advanced work, including the C-17. That was involved. Mr. Patton has received numerous honors, including an election as a fellow in the American Institute of Aeronautics and Astronautics. He also was elected to the Engineering Hall of Achievement of the University of Texas at Arlington. He received the Reed Aeronautics Award as the most outstanding aircraft designer in 1986. In October 1997, he received the Decoration for Exceptional Civilian Service from the Secretary of the Air Force for his 4-year work on the Scientific Advisory Board. During February 1998, he was elected a member of the National Academy of Engineering. In 2003, he received University of Michigan's Aerospace Engineering Alumni Society Merit Award. In 2004, he became a member of the Academy of Medicine, Engineering, and Science of Texas. He continues as an active member. I don't know how you had time to do anything else. Did you ever see mine? Anyway, this gentleman here will be able to tell you everything you ever want to know about B-2. After he is through speaking, he has 3 colleagues that will come up here and we'll have a question and answer period. And what we're going to do this time is I'll call him down here. You're going to ask the question to him and he will either answer it or we'll turn it over to them. I will pass the microphone up for the question. So if you raise your hand, I'll send the mic up and ask your question so we can hear it and they can hear it. And then he's ready with the mic and we have the other mics here. So if you would, and without further ado, I would like to introduce Bob Patton.
I don't need that, right?
No, you don't need that. You're good to go.
Now,
So
how do we get this thing back? Okay,
I think this is yours.
that's it.
Now you know how to do the rest. See, I know how to do somebody else's. They just don't know how to do it for me.
All right, let's.
Oh, he's going to do it. Yeah.
I hope that works. Worked? Okay. Everyone hear me okay? Good. Thank you all for coming. I'm pleased to be here. It's, you know, it's very different because for too many years working with programs in the black world and stealth, you not only couldn't talk about them, you couldn't even admit they existed. And even my wife didn't know where I was. And, you know, it was very different. But fortunately, there have been all sorts of things cleared in the last few years. And as such, I've tried to put a number of those together tonight to give you the background for stealth and also really tell you a lot about the B-2. So very quickly, I want to talk about the early stealth work, the conceptual studies, then the preliminary design period, and a lot of people don't realize it was a competition. Even though it didn't exist, there really was a competition, believe me. And then after that, there was the preliminary design, the usual problems, then finally get out of that, you get into detailed design, testing, deduction, initial operation, and in the case of the B-2, I think I have some good stories to tell you about it, and then where we are right now. Now, this is the B-2. I think it's a pretty airplane. It's very different, and it is designed to be stealth. Now, what do we mean by stealth? Well, in the early days, what it was conceived of as the ability for a bomber to attack a target without anyone knowing it ever been there. And that is that it was without being detected. That meant that you couldn't see it on radar, you couldn't visually detect it, you couldn't hear it, you couldn't see contrails at altitude, you didn't have any infrared signature that was identifiable, and there wasn't any electromagnetics. The radars and so on didn't disclose its whereabouts. Pretty difficult set of requirements. Most people think of stealth as radar, and actually that's primarily where it started. But when the concept came along of a whole airplane that could do things and nobody ever know it was there, it involved all of these items here. Now, the early developments, this takes us back, 30 plus years. Actually, it's earlier than that, because on things like the F-111, we had a lot of RAM, radar absorbing material, was put on the sides. It was put up on a pole and tested with radar, and where we had big spikes return the radar, we put RAM on to knock off those spikes. So the 111 was not nearly as vulnerable to ground action as it would be without treatment. So there was all that, and you're all familiar, I'm sure, with the SR-71, which was a 1960s type airplane, and it had those big chines, and those chines were filled with what we called hair, and they were partially radar absorbing, so that even at high altitude, 70 plus thousand feet, why it did not reflect totally back to the ground stations. So there was that early developments in RAM and materials, and as they progressed, the idea started generating that maybe we could come up with an airplane that would be able to attack without actually anybody seeing it until it was gone. It had done its job and it was out of there. So in 1974, DARPA, the Defense Advanced Research Agency, they let contracts to McDonnell, Northrop, and Boeing, and there was a program called Project Harvey. A lot of you may remember the stage play that had Harvey in it. Harvey was a rabbit, but he was an invisible rabbit. And he participated in all sorts of things, but it was an ideal name for this program that was trying to come up with an airplane that wasn't visible. So that was called Project Harvey. It showed a lot of promise. And the next step, why they came up with what they called the Experimental Survival Test Bed, the XST. And for this program, they let a contract to Lockheed to build 2 airplanes, and Northrop, they gave them a contract but not to build an airplane. So Lockheed got a contract to build 2 prototypes and fly those. These are all classified and didn't exist, remember? And the Lockheed program was called Have Blue. And it was from June of 1975 through 1979. And it was successful enough that they went ahead with the F-117 out of it in November of '78. Now about that time there was another program which was looking at stealth in a different way, and this was the battlefield surveillance program, which was designed to have something that was invisible but hover over a battlefield and tell the Army where to shoot and where to watch out for. And Northrop had a contract there, but a whole different concept of stealth. Whereas, as you'll see, the Have Blue was a faceted type airplane, so the radar waves would bounce off harmlessly into space and not be returned to the transmitting antenna so it could be detected. The Tacet Blue, which is the Northrop program, was a very, very different type beast. Now this is the Lockheed Have Blue. And you know, it looks a lot like a 117 until you look, whoops, those tails are turned in. They're not turned out. This one they were trying to cover up the exhaust on this. It has somewhat different, the inlets were a lot like the 117. They had screens in them to keep the radar out. But it was very much similar to the 117. So the 117 was a direct outgrowth. I mean, it was a reasonably successful program. That's the key part to it. Now, the thing that we have to, in looking at this Have Blue, what really happened was the first one of these, now they took them up to Groom Lake, and that's where they flew them. And this first flew in December of 1977. And it lasted about 6 months, and then it had a hard landing, and it kind of fell apart, and it wasn't flyable, and they didn't know what to do, so they got a bulldozer in the desert, they dug a big hole, and they buried it, and nobody knows where it is today. The second one flew 6 months later, and it lasted a little while. It had a hydraulic leak, and it started burning, and it burned up, so they went out and they dug another big hole, and they buried it, and nobody knows exactly where it is today either. So the 117 came along immediately after it, and of course it was very successful. The first one was delivered in 1982. This airplane is about the same size as an F-22. It's not a small airplane. It has two engines, two F-404s. It's 66 feet long and it weighs 52,000 pounds. So it's a good sized airplane. It was first used in Panama in 1979. Now, at the same time these things were going on, Northrop was building Tacet Blue. And here is the Tacet Blue airplane of Northrop's, and the one above it, Boeing didn't get a contract, but they went ahead and built their version too. They thought they might get in the act. So they built one, they called it the Bird of Prey. It never flew. But the Tacet Blue was actually built, only one of them was built, but it flew first in February of 1982, and it made 134 flights. Now, as you can probably see why, it was nicknamed the Whale. It kind of looked like it's in contrast to the 117, which is a faceted airplane. You can easily see this is a totally different concept of stealth. This is rounded surfaces, pointed edges, and so on, but no faceting to speak of. This is a smaller airplane. It's just 30,000 pounds and 48 feet wingspan. I might just note that Boeing tried to get into this, but they made out all right because the battlefield surveillance mission eventually was taken over by what became the E-8, the 707 version, Boeing's that has all the electronics in it to do the battlefield surveillance mission. Now, while these things were going on, the fact that the 117 was so successful, and at this time the Air Force was worrying about their B-52s falling apart, being too old, and they wanted a new bomber. So everybody knew there were all sorts of studies being done on new bombers. So Lockheed in 1979 proposed a larger version, basically of the F-117, to be a replacement strategic bomber. The Air Force, looking around, wondered about, and I guess Northrop suggested flying wings. Now, a lot of you may remember that the Northrop flying wing, the X-35 and X-49, were competitors to the B-36. And back in the late 40s, we actually had a fly-off between them. which fortunately the B-36 won. The flying wing was actually way ahead of itself. It needed today's fly-by-wire sensors and computers in order to make it controllable. It was not easily controllable enough, so it was a good thing the B-36 won. But that design was a good design, particularly for high altitude work, and it was very streamlined, hard to see, not very big. So the Air Force asked Northrop if they would look at possibly using the Tacet Blue type approach to things to make a bomber version of a flying wing. So by August of 1979, it really looked like that there was really a market here. There was going to be a new bomber come. It was either going to be a big 117 or it was going to be something that Northrop came up with. And as a result of that, both companies started positioning themselves for a competition. Lockheed knew they had to have a radar outfit that could take care of the low probability of intercept radar, so they teamed with Raytheon. And Northrop was told they didn't have any bomber experience, so they went up and talked to Boeing, and then eventually talked to us at Vought, and they went out and teamed with Hughes to do the radar. Now, teaming under these circumstances is not easy. In the black world, first of all, you have to be cleared. You know, only cleared people can even know the program exists. The level 1 clearance is just the knowledge that the program exists and some idea what it is. Level 2 is some generalities as to more than that. Level 3 is most technical details, performance, and program. Level 4 is strictly all of the stealth stuff, everything that makes it really stealthy. So you got 4 whole levels of different clearances to go through, but to even get somebody cleared for level 1 took anywhere from 60 to 120 days. Didn't do that. You filled out lots of forms and you went through the FBI and all that and so on. So in order to team, you had to get the Air Force to agree that you could go team with somebody, you know, and say, well, who can we get with? In the case of Lockheed, Northrop teaming with Boeing, the Air Force suggested that Tom Jones, who was chairman of the board of Northrop, go talk to T. Wilson, who was the chairman of the board of Boeing, and that they would clear it and tell them, okay. So Tom Jones went up to Seattle, and they closed the door, and security guards and everything, and he explained roughly what the program was and that they wanted to team with Boeing. And T said, well, yeah, they were really interested now that he had some idea. And as soon as they left, he was livid. He called 2 or 3 of his people. He said, don't you ever let me be surprised like that again, not knowing anything exists. Well, he came around and learned and was a good supporter of the program. In the case of Vought, we had Bob Parker, had good close connections with both Northrop and the DARPA, and so we talked with Northrop, and in this case, after some preliminary discussions, they said, well, okay, we'll give you 5 tickets. You can clear 5 people, and we'll talk and try to decide how we team together. Well, you can probably guess how that would work out. With 5 people, I was the vice president of engineering, and I was the guy who was going to have to run this thing. The president of the company got cleared. Bob Parker, who was the senior vice president, he got cleared. And I had to clear a security guy, and I cleared a contracts guy. So that was the 5 of us. That was all there was. But then, once we had our clearances for the 5, they said, all right, 3 of you can come out to California, and we'll brief you through level 3, and then we can really start working together as to what we're going to do and how we're going to do things. So, 3 of us, the security guy, the contracts guy, and myself, flew to Los Angeles, and my instructions were I had a phone number. When I got to LAX, I was to call that phone number, and I'd get my next directions. Where would I go next? And so I got them, and they said, rent a car and drive east, and when you get far enough, you come to Chadron, you turn right, you see an old building on the right, there's a little parking lot behind it, pull in there and come in that door. Well, east part of Los Angeles is not a real nice part of town. We're driving out there and looking and we're going to just park it. Then we finally found Shadron. We turned right, turned into the parking lot, and man, this is old ramshackle warehouse. It looked like nothing. You know, do we really want to go in there? So, okay, go in the door. Go in the door, and there's a security, a receptionist and this guard, and he says, sit down, you know. So you sit, you give them your driver's license to identify yourself, and eventually they come out, and then they take us one by one in and fill out stuff and secure it. You swear you're never going to tell anybody anything, and so on. So the three of us finally got cleared, and they did brief us, and you know, but it was getting more people cleared. It was a real chore. So it was a challenge all the way through in doing this. Now, looking at the work split that we ended up after all the negotiations, who was going to build what? The blue area here is the part that Boeing had. They had the outer panels, which I guess the logic was they looked like 707 or 747. One of our problems was that they kept wanting to design it like it was a 707, and it wasn't. It was a whole different airplane. The outer panels here were almost all the airplane on the outside, all the skins are composite. The requirements, the smoothness requirements for the radar and so on were absolutely so stringent that everybody went to composites. So everything you see on the outside, and most of the understructure was titanium. Well, Boeing had this large outer panel. They built a special building and protrusion type composite lane to make these panels, and then they built a brand new secure 60-foot autoclave to cure it in, the largest one in the country at that time. So they had all those investments to make that. Boeing also had the aft center fuselage, everything aft of the crew compartment bulkhead. So it was composite, but almost all of that area is just the weapon base. This airplane has big weapon base. The Vought case is the orange stuff shown here, which is the intermediate wing, which included in the inboard side of our intermediate wing is where the engines are. Two engines on each side. This is a 4-engine airplane. And on the outboard of the engines is the landing gear wells. So they're all big, and this panel on the top is probably the biggest panels. And I've got a sample in my briefcase over there of how thick it is. It's about that thick, over 200 plies, all laid up progressively along the way, and had to be to this very exacting specifications as to the smoothness. We had a 2-year program that we undertook to build these panels, take them apart, inspect them, find out what was wrong with them, and then go back and try to fix that and rebuild it. We finally learned how to build them right, which was a good thing, but it's a very difficult process to get into and was a long time going. The aft part of the intermediate wing, this little tail end piece here, is the piece that's under the exhaust from the engines. Because of infrared and the fact that we're planning to fly at high altitude, you didn't want any exposure to that hot engine air from the beneath, so the engines had their exhaust moving over this back end, which made it pretty hot. It ended up being a welded together, full one-piece titanium piece back there. Northrop had the crew compartment area, and which was relatively conventional, but the big thing, Northrop had all the edges, all the real stealth stuff, which were so critical of the design. So all the way around the airplane, they had that, as well as the integration. The engines, GE won the competition for the engines from the Air Force, and as I already mentioned, Hughes was the contractor we had for their radar. Now, they actually issued an RFP, said we want proposals, and here's what we want by late 1980, and we were just working, just about had the proposals done when the Air Force came in and said, oh, we want to change the proposal, you know. We don't just want a high altitude airplane, we want it to be high altitude and to be able to go into 200 feet. Well, those are two very different environments. And it created a lot of havoc. We made some changes in the design. The other thing they wanted provisions for a third crew member. And so the bulkhead got moved back, and we made space for a third crew member. So the proposals were modified. They were finally put in around June. And in October, they announced that Northrop and the team, we had won. And you know, there was a lot of joy. At this time, you know, the difficulties of doing this with Stealth World, by the time we made the proposal at Vought, we had 12 people cleared. We did the whole thing. I mean, this is why these programs weren't real expensive. You didn't have enough people to spend a lot of money. But we had a secretary cleared among our 12, and Northrop was short. They only had 1 or 2 secretaries for the whole proposal, so we had to send our secretary out at West Coast for a month or so to help write the proposal, help type the proposal, because we were so short on them. The other interesting part was when we won, everybody was elated, needless to say, and we said, well, we got to have a party. Well, where do you have a party when you're winning a contract that doesn't exist for an airplane? It doesn't exist. Well, we had it at our house. That's where we had it. We had trouble explaining it to the neighbors as to who they were. One other aspect here, in this period, Northrop was very sure they had won, and they had purchased the old Ford plant in Pico Rivera, in north part of Los Angeles, and they leveled that old plant, and they built a whole new facility, which was a very nice facility, which is also where they did all the development work for their edges, the RAM, all that was done there, and the manufacturing of it. They also built the crew compartment there, and we all met there regularly to integrate things. The actual contract, of course, came 2 months after getting the proposal, and being declared a winner. And then you started the real nitty-gritties of the development. Typical was we had a lot of wind tunnel testing to do. Like everything else, you had to get the people at NASA cleared, you had to get the facility cleared, you had to get everything cleared. It just went slowly, and as such, the program was probably a little slower than it might have been otherwise. Another element, you had to clear all the subcontractors. Now, one nice note here about in this period was the design was firming up, and we had some models in the classified area. But Jack Northrop, who was the father of Northrop Aircraft, was in the hospital and was terminally ill. So John Paterno, who was the program vice president for Northrop, he talked to the Air Force, and the Air Force agreed that they would bundle up the model and everything and put it in an Air Force van, and they took it all to the hospital, and they cleared it way in the hospital, and they cleared the room for Jack, and went up and they showed Jack Northrop the model of the B-2 and said, your flying wing is going to really happen, And Jack died about 3 weeks later. So it was a real nice thing to happen, and the program has real people. Now, as you might guess, as you get into the development, things aren't all the way you thought they were in preliminary design. It just doesn't quite work that way. And here's where we were. On the left is the original proposal design, and on the right is what we finally came up with. Now, the original design had, on the leading edge, the ram was 30 inches deep, about that deep, and as such, the front spar sat behind that. But the inlets got moved forward for, again, stealth reason. So the inlet ducts actually went through our main box in the front part of the airplane. So we had very high loads, and we had the loads at the corner between, at the corner here of the crew compartment and the intermediate wing. These loads looked we weren't even sure we could put enough metal in there to handle them. Then the real kicker came along when we finally got enough NASTRAN work and loads work to understand how the airplane, how flexible it was and what happened. And what really we found was that with this design, when the here, if with these control surfaces, if you tried to turn the airplane to the right, those went down. But when they went down, there was enough flexibility in that whole side of the airplane that it turned and they were ineffective. So we really didn't have enough control effectiveness with the design. So back to the drawing board. There were 3 teams formed. We had a team at Vought, we had a team at Northrop, we had a team at Boeing. Each of us did our own pre-design work for about 4 or 5 weeks, coming up with all different designs. And then we all met together and we merged them. And it was a real good team effort, really. It was a delightful thing to work on. We finally came up, the good news was that Northrop had been able to develop a shorter ram, 22 inches instead of 30 inches. So that gave us another 8 inches there. We were able to move the engines back about another 6 inches. So now we had a decent box for the wing going in because all that stuff was behind it. And the really big difference was that we had to go to a sawtooth, which is this here, and put in more control surfaces there. With those, and also putting that in stiffened up the wing considerably so that we had good control and the airplane was very good flyable shape. So that was the design that we finally ended up with. And there was another PDR held in late '84. Now, one of the design requirements, it's an interesting one because having a team like we had with pieces being made in Seattle, pieces being made in Grand Prairie, pieces being made in Los Angeles, they all had to be transportable by air. Every one of them had to fit in a C-5. So we had C-5s because the final assembly was going to take place in Palmdale. And it was a whole new facility built at Palmdale on the black side where the Blackbirds and we see F-117s were on that side of the field. So they built a huge new facility there to assemble and build the B-2s. Now, with a C-5, you may not realize, but it was very restrictive on the design. Actually, the Boeing outer wing had a little piece chopped off, and we had that as part of our intermediate wing because with that piece it wouldn't fit in the C-5. And for us, we were worried about whether the intermediate wing would go in the C-5. We built a template of the max cross-section out of plywood. We took it up to Aldous, Oklahoma Air Force Base and literally walked it through a C-5 to make sure that it would go through. And it did. It was outside the cargo master's normal envelope, but it still fitted. So we were home, we were there. So as we assembled the airplane and we got the pieces put together, we finally got our intermediate wing sections built over in Grand Prairie. C-5 flew in right after dusk to the Naval Air Station. We put the whole intermediate in the C-5, takes off, flies to Palmdale, lands, and it goes into the factory there. Same thing with Boeing up in Seattle, and that's how the plane, all the pieces got there. And in Palmdale, it all got put together. And in November of 1988, we had the rollout. This picture is after it rolled out. They had stands all around the periphery here, and they're very closely guarded and so on. And of course, when everyone got there, the doors were closed and the airplane was inside. So the band played and the speeches were made, and then they opened the doors, and out came the B-2. So it was a great day. It was November 22nd, and one extra special part of it was that I mentioned John Paterno to you. He was a good friend and a very good program leader. He had terminal cancer at this point. They put him in an ambulance and drove him all the way to Palmdale and put him in a wheelchair, and he sat there and watched it roll out, and then they took him back and he died a few weeks later. So once more, the human side came out. First flight was the following July, and I went to Palmdale 3 times to see the first flight, and I never saw it. I was in Washington when it finally flew on the 17th of July. It took off from Palmdale and it flew to Edwards Air Force Base, and it never came back to Palmdale. All the airplanes were built and assembled at Palmdale, but they made one flight out of there, and that was to Edwards until they started delivering them. All the flight testing was done out of Edwards, and they had a special area over on the classified side there with where they could operate out of. The structural testing was completed by mid-93. Subsystems, the same thing. There were 5 airplanes to be in the test program. You know, some airplane programs have, the F-111 had 30 airplanes for testing. This program only had 5, and all 5 were considered or always planned to be converted to production airplanes for the use of the Air Force. Airplane 2, which was the first of those, was flown in October 19th of 1990. And the first production airplane was actually delivered to the Air Force in December of 1991. Originally, they planned to build 132 airplanes, but there are things like budget cuts and changes in administration and all that. And the net result, we ended up with building just 21. And so the 21 were all built and produced there. One of the most time-consuming parts of flight testing is qualifying all the different weapons. The B-2 has, I mentioned, 2 large weapon bays in the center fuselage. It can carry 50,000 pounds of bombs, and it carries all, it's both nuclear and conventional. So you go through and you have to actually test and drop and qualify for all these. So that's a major part of the development program, is the flight testing of these weapons. Part of that, of course, is one of the things we try to do to speed it up is to refuel so you can spend a little more time in the air. That's what it looks like with the KC-135, I'm sorry, DC-10, KC-10. And this is what it looks like to the boom operator up there, kind of a different view. Now the production went ahead. This is a view of the inside of that plant at Palmdale. This is a large plant. It was about the size of 4 football fields. It's a huge facility. When we were originally building it, we worried about the stealth aspects. You know, we knew the Russians had satellites, and we used to say, well, surely they'll see this great big thing, you know, and they thought to find that there's no way of hiding it. It's just grit your teeth and bear it. But inside, it was all, no windows, anything. But this shows the B-2 in the process of being assembled. Now, the final airplane, just refresh you, we've got a wingspan of 172 feet. The airplane is 69 feet long and has a height of only 17 feet. Doesn't have a tail. We're using those elevators on the split L-bombs on the wings to do all that. To put some of this in perspective for you, I thought a lot of you probably are familiar with either B-36 or B-2, 52, or B-1. Here's a comparison of the 4 of them. And the B-2 is wingspan is kind of in between, 172 feet. B-1 is only 137. The B-52, of course, is swept back a lot, so when you just measure from tip to tip, it's 185. The B-36 was 230. It had a lot of span. The length, the B-2 is short, is only 69 feet. The B-1 is 144 feet. The B-52 is 159, and the 36 was 162. The gross weights, the operating weights, the B-2 max in-flight weight is 357,500. Its actual takeoff weight is about 335. That's all the gear is designed for. So it needs to be refueled to get to this weight to go further. The B-1's a 477 gross. The B-52 is 488, and the B-36 was 410. The weight empties are interesting. 150,000 pounds, what the B-2 weighs at. Got a lot of composites, as I mentioned. The B-1 is 192,000, B-52 is 185, and the B-36 is 171. The range, about the same. B-52 used more of the low-altitude airplane with that swept back. It doesn't have quite the advantage of the really high aspect ratio the other three have. Number of crew, the B-2 has just 2 people. It only flies with 2. And the B-1 has 4. The B-52 needs at least 5. And the B-36, they say it's 9. I never saw it with less than about a dozen. And sometimes it seemed like there were 20 of them would get on board. Of course, I guess if you were flying, well, B-36 flew some mighty long missions too, so that's in fairness to it. Now let's look at the operational use. When these airplanes were built, all of them slowly delivered to Whiteman, all of them based at Whiteman Air Force Base in Missouri. The Air Force decided one base, go either west or east, either way. And the first operational use was in 1999 when decided that we needed to take care of Kosovo and those Serbs over there. So they were ordered into action into the Kosovian War. And the Serbian defense network had essentially been built by the Russians. It was a very sophisticated defense network, and we were rightfully quite concerned about it. So on the 24th of March, the first missions were flown. And they were dropping JDAMs, the Joint Directed Attack Mission, with GPS guidance. And the nice part about this, we felt that the B-2 made a really perfect weapon system because you're bombing from roughly 50,000 feet. You've got a target that's specified in coordinates. You've got a weapon that will hit in terms of coordinates. You drop them and it corrects itself and wimp. You really do a great job. So what they did during this war, they flew in 1 or 2 ship missions. They were arranged so that they would strike the targets at night in Kosovo. All missions were flown out of Whiteman, Missouri, all the way to Kosovo. About 30 hours of flying total, and 90% of the bombs they dropped were within 40 feet of the target area. So they had an absolutely great record. They've also been used in Iraq and Afghanistan. Now, the JDAM, typical, they dropped 650 JDAMs in Kosovo. I mean, this was no small operation that they were carrying out. They dropped, normally they were 2,000-pound JDAMs, although they dropped a number of 5,000-pounders. So, and some of the airplanes actually dropped 16 JDAMs on 16 different target locations. So, I mean, that's how they went. They would take off from Whiteman, refuel out over the mid-Atlantic, then when they got about an hour away from the target area, they would refuel again so they'd have plenty of fuel, and then they'd go in and they'd fly all around, dropping bombs as they go back out, get refueled again, and then get refueled a 4th time in the mid-Atlantic and return to Whiteman. Now, during that time, they found, it was pretty boring. It's a 30-hour mission and you're about an hour in the combat area. The rest of the other 29 hours are just you want to watch some TV or show or something. The guys told us we were very fortunate in that we participated in the 10th anniversary of first flight, which was in July of 99, which was 3 months after these attacks in Kosovo. And the crews that flew these missions were all invited to participate with us at that time. And they briefed us on what they'd done. They had lots of pictures and movies and so on. They show how their accuracy, that how they could hit, they would attack and drop a bomb at the intersection of each of the runways and the taxiways. So they would totally shut down the airport for 3 or 4 days and then they come back and do it again. They were able to knock out the bridges, each end, the abutments there. The accuracy of this combination of high altitude and the GPS guided bombs is just really wonderful. And the crews told us how that when they flew over, they'd alternate. One of them would fly, and the other would, they bought some beach mattresses and put behind the seats, and they can lay back there and lay back and take a little nap. So they both be refreshed by the time they got to the combat area. So, one other interesting story they told us, and I guess it's okay to tell it. You probably all may remember in the Kosovo operation, we bombed the Chinese embassy. And the Chinese protested vigorously. Well, it was well known that the Chinese embassy was actually the centerpiece of all of the intelligence gathering and direction of the other side of the war in Serbia. You know, they were the guys that you want a prime target, that's it. So the fact that they had a Chinese flag on it was just, it's like some of these civilians in Afghanistan. Oh, you hit a civilian. How do you know? He just didn't have his uniform on. But anyhow, the guys that flew the missions told us, they said, you know, when it came to the Chinese embassy, it wasn't really a mistake. We dropped 4 bombs. We hit all 4 corners of the embassy. It's right on. So, you know, it really works great. Now, they were deployed again in 2001 and 2 to Guam. They participated in the Afghanistan mission. Some of them are 44 hours. They'd fly out of Guam, bomb targets in Afghanistan, fly on to Diego Garcia, refuel, rearm, fly back, bomb more targets, fly back to Guam. 44 hours. 1 crew, 1 airplane, kind of brutal. They were also committed to the Operation Iraqi Freedom, and I can't get away without mentioning the fact we lost an airplane in Guam. The stealth characteristics mean you can't have a pitot tube sticking out returning radar signals. So there is no pitot tube. The airspace system has to be very stealthy. It has to be within the confines of the outer mold line of the airplane. In this case, in doing this, it is the system on the B-2 is very sensitive to moisture. And Guam is a very high humidity environment. And the maintenance crews in Guam did not go by the book as to what they needed to do to properly maintain that airspeed system. So when the poor pilot started taking off, the airspeed system went ape. It required a full pull-up and over. The pilots were smart. They punched out, and at least they survived. So it wasn't any part of their fault. They were just sharp enough to get out, but it sure drove the lesson home that these airplanes are wonderful, but they're also very delicate, and they have to be taken care of properly. Now, all 20, since they lost one, they went back and redid Airplane 1. Airplane 1 was like most initial airplanes. There were a lot of engineering changes that came along in airplanes 2, 4, 6, and 8. Well, after the flight testing, they went back and modified Airplane 1 to bring it up to speed to what all the rest of them were. So they now have 20 operational airplanes, and they've all undergone a lot of renovation. Well, you'd expect that. It's been 20 years that I'm talking about, which is why it's clear not to talk about it. But so they've all had improved new coatings that have been developed. They've got new RAM, they've got a better radar, and they've got improved communication systems. So they're in tip-top shape, and the only thing we can cross our fingers and hope we really don't need them, but they're there. They can go any place in the world. That's the nice part of it. Anywhere in the world, and we got young men and crews that are just great guys that are capable of doing that. So we can all be thankful we have them, and I was really pleased to be a part of that development. Now, Bob said we'll take questions. So that's the end of mine. So Bob, you're gonna, where'd you go? Oh, here you are. You're gonna turn that out.